Hello my dear students. Today we are going to discuss about the ST and VT graph, that is displacement time graph and velocity time graph. But in the last video we already discussed about speed, velocity, displacement, your distance, acceleration, about all that. If you haven't seen the video, then in the description box the link is given. You must see the video. That will be helpful for you. Now in ST graph, that is in your displacement time graph, suppose the equation is given as S is equal to T square. Okay. So if you plot the graph, then by the equation you can understand that here we are going to get some parabola. Okay. This is that parabola. Now if you are asked to find out the velocity of it, okay, so what is the relation between along x-axis? Here you are plotting t, along y-axis you plot s. Okay? Now here one question most of the time I have seen from the students that along x-axis which one I should plot, t or s? They are confused. Actually there is a thumb rule. Okay, you have to remember that along x-axis we always have to plot independent one. Independent means there you see that time doesn't depend on anyone. Time is always independent of s. Time is always independent of s. But s depends on t. S depends on time. So the dependent term will be plotted along y-axis and the independent one will be plotted along x-axis. So x independent, y dependent. Thus you can remember. Now, as I was telling that here V, if we are asked to find out, see that S and T is known to you. Then what is the relation between Vs and T? V is equal to delta S. If I here tell delta S over delta, okay, and when delta T tends to 0, then it goes to, delta is very small, then it becomes ds by dt. Okay. This is actually V average and this is your V instant. You remember already we have discussed about all this. Now how to find it? Okay. Now suppose at t is equal to 4, you are asked to find out. 4 means here is the point. You are asked to find out the velocity. Then what you have to do? Here you have to plot a tangent like this. Okay? You have to plot a tangent at this point with angle theta. Okay. So what is the slope of this tangent? Slope of the tangent is equal to your tan theta. Slope is equal to tan theta. Okay. Now here we know that tan theta means nothing but your perpendicular over base. Okay, perpendicular over base. In that case, how you can find it? See that slope is equal to tan theta is equal to ds over dt. Okay, slope is equal to velocity. Now if you are asked to find out the velocity, see how you can calculate. You can find out tan theta, you can find out ds by dt. Okay, there are two ways. And tan theta is equal to, we know that is equal to perpendicular over base. Okay. So this is the way you can find out the velocity. Now here you see that in this case, you can calculate the value of perpendicular, you can calculate the value of base, and then you can get the corresponding tan theta. Also if theta is known to you, then also you can calculate tan theta. And also if you have S equal to T square, see the equation is given, isn't it? So if S is equal to T square, then you see that ds by dt, you can do the first derivative and you can get the corresponding result as 2t at t is equal to 1. So therefore ds by dt, ds over dt at t is equal to 1, the value would be 2. Okay. So this is the way, different way how you can find out the velocity from the ST graph. Okay, ST graph. Now next is VT. Okay, so suppose for VT you are getting some straight line. to get some straight line like this. Okay. Now if you are asked to find out the displacement, okay, then what you know here, see, along x-axis it would be time, along x-axis it would be time, and along y-axis it would be v, right? So v and t is known to you. Then how you will calculate the displacement? See that as we know that v is equal to ds by dt. Therefore, s will be equal to integration over v dt. Now here is the thing that s is equal to integration over v dt means here you always remember that v dt means area. Area under the curve. Area under the curve. You always remember here. Okay. Curve. Okay. So how the area would be calculated? Here you see that if this is the graph, now you are suppose asked to find out again, you have to find out the displacement at time t is equal to 4. That means at this point. Now what you will do, you just here draw a straight line like this. That means the area under the curve would be this one. So here you have to find out the area of it. Suppose I am giving the name, all these are the general formula. Okay, to calculate it, you always remember whenever you get any numerical regarding this ST and BT graph, you always apply all these formula, all these methods. ABC, okay, ABC is the triangle. Now this is the area. So area if you have to find out, then the formula, as you know, that area of triangle ABC would be is equal to half multiplied with base multiplied with your height. Okay, this is the way to find out the S for this kind of VT graph. Okay, now if you are asked to find out your acceleration, okay, acceleration A, then dv by dt. Now here you see that there is a similarity with the previous discussion, that is your velocity from ST graph. See, v is equal to ds by dt, and here a is equal to, instead of v here we have acceleration a, and instead of s here we have v. That means a is equal to dv by dt. This is the acceleration. So in that case also you have to calculate the tan theta. Dv by dt means tan theta, which is equal to slope. Okay. Same way, here also if v equation is given, then with the help of it you can calculate a. Okay. Also, if theta is known to you, suppose here the theta is the known to you, here the slope is this, and slope would be also the here same. Though if theta is given to you, if theta is known to you, then you can calculate tan theta. Okay. Also, if another way you know that if suppose you are asked to find out the your acceleration at this point 4 again, then what you have to do, if tan theta you want to calculate, then also perpendicular over base. That means you have to find out these 2 points, that is B and C, right? Then you have to calculate tan theta again with BC, that is the perpendicular over AC. Okay. Same way, with same way you can find out the acceleration. Means you remember that whenever you are asked to find out velocity using ST graph, then you have differentiation, and there that story of slope, tan theta, ds by dt, and then tan theta is equal to perpendicular by base, there are different ways, and now you have to choose that which one you want to use to calculate the velocity. That depends only on the numerical. Okay, which values are given, using that values you have to choose the formula. Okay. Now similarly for VT graph also, you from the VT graph you can calculate S as well as your acceleration. Okay, so this is about the ST and VT graph, basic idea about the ST and VT graph. Now when we will do the numerical, means now we are going to do the numerical, then it will be more clear. Also with all type of numerical today we are going to do regarding ST and VT graph. So ये जो video है वो थोड़ी लंबी होने वाली है, so you must watch the whole videos and you must keep your pen and paper with you, and you must do the numerical what we are going to do. Now here you see that the 6 numerical from HC Verma. This is will be quite easy for you because we already have discussed the whole theory, isn't it? So now you see that the speed of the car as a function of time is shown in figure. See, the figure is given here. Figure is given. Using it. This is the figure. Yellow color thoda better, isn't it? I am using the yellow color. It is more visible to us. So this is the figure. Now find the distance traveled by the car in 8 seconds. You have to find out. That means if this is your 8 second, at 8 second you have to find out the distance. So V is given. Along y-axis V, along x-axis you have time t. Okay, here you have 8. Here you have 8. And the corresponding value of V is 20. Okay, now first you have to find out the distance S. Now few minutes ago I told that if V and T is given, then what would be the relation? S is equal to integration over V dt. That means integration means area you have to find out of that triangle, right? Here you see that this is, suppose I'm giving the name as A, this is your B and this is your C. So this is the area under the curve, okay? So this is the area under the curve which you have to find out. This would be the value of the distance. Okay, next also you have to find the acceleration. So A is equal to dV by dt. A is equal to dV over dt. That means here you have to find out the slope of it, that is equal to tan theta. That means here we are getting, see that we can get the value of the perpendicular and base. So I choose here the method of finding the value of perpendicular over base. I choose this one, okay. So if first we calculate A is equal to the value of perpendicular means BC, right? BC means 20. This is the 20 value of V is 20 here, and at C the value of V is 0. So obviously the should be 20 minus 0, and if you see here base A and C, what is the value of C here? 8. So therefore it would be 8. Okay. So this is the value, that is 20 over 8. That means here we are getting it as 2.5, and the unit will be obviously meter per second square. So this is the acceleration we have got. Now distance we have to calculate. So S is equal to VTT. Now here I choose the formula, that is half multiplied with base multiplied with area, right? That means we have to here calculate the area of this triangle ABC. That means here is equal to half multiplied with base, means here you see AC, that means 8, and area is here, sorry, this is not area, this is height. This is height, base into height. I was thinking about area, that's why I have written area. Height. Okay. Height means here it would be 20. Therefore, you are getting the value as only 80 meter. So this is the answer of the displacement, this is the answer of the acceleration. Now here is your next numerical. The figure is given, here you see that the figure is given with time t equals to 0, the cart started and you have to find out the distance in 30 seconds. Okay. Now if you give the name as A, B, C and D, then you have to find out SAD. SAD is equal to what we can write SAB plus SBC plus SCD. Okay. 3 times we have to find out the distance of the cart. So how we will start with SAB. Okay. We will start with SAB is equal to, now here you see that the acceleration here is 5. It is constant from 0 to 10 seconds. But here at time t is equal to 0, we can consider u is equal to 0. So if I use here the formula ut plus half a t square. Now since u is equal to 0, that means here we have 0 plus half a is equal to, here the value is 5, right? And time t is equal to 10 square, that is 100. That means half multiplied with 5 with 100. So therefore it is 50, gives you 250. 250 feet. This is the first value. SAB we have calculated. Next we have SBC. Now you see that in BC, okay, between B and C point, it is going with the same velocity. Okay, the velocity doesn't change. No, there is no acceleration. Acceleration 0 means velocity is constant, isn't it? From B to C. That means we have to here find out the velocity at the point B. So how we can find it? See, we know the formula V is equal to U plus AT. So here you see that U is equal to 0. Okay, I am giving the name as VBC. Okay, then it will be better for you to understand. VBC is equal to U plus AT. Okay, is equal to, here since U is equal to 0, so therefore A is 5 and here time t is equal to 10. T is equal to 50 feet per second. This is the velocity with which the particle goes from B to C. Okay. Now we can calculate SBC because we know the velocity. So therefore SBC is equal to velocity multiplied with time, VBC with time. VBC just we have calculated 50 and it will be multiplied with time, that is 10, which is equal to 500 feet per second. Clear hai na? Next we have SCD, we have to calculate. Now here SCD, for SCD again we will use the formula, that is ut minus half a t square. Okay. Here you see that a is negative, right? A is negative. Now for this SCD, what we can consider that u is, here we know the value, u is the 50. 50 will be S. Why? Because here you see that what the velocity will be at B, same will be at C also. So that's why here u will be again 50. Okay. Time t will be 10 minus half of, here a is 5. Okay. And here time t is 10. So if you here calculate, then what you are getting as, so here t square, so it would be 10 square. So 50, here you have 500 minus, again you are getting it as half multiplied with 5 multiplied with 100. Okay, so this is your 50, that means you are getting as 500 minus 250. So the value would be 250. Okay, feet, it is feet. So it would be, this is the value of SCD. Now you see that we have calculated all the values of SAD. Now we will just sum up them. So therefore SAD SAD is equal to 250 with 500 with 250 gives you 1000. Now here you see that first you have to plot the graph of position time graph. You have to plot. So first let me plot it. Along x-axis time, along y-axis you have position. Okay. This is your time and this is your position S. You have to find out, you have to plot the distance. Now first we will go for SAB. So to calculate SAB, first we will go to equation. Okay, here you see that V is equal to U plus AT. That means since here U is equal to 0, therefore V is equal to the value of A is 5, so 5T. I have given it as equation number 1. So V is equal to 5T if you plot, means V is equal to 5T. If I write it here, from this equation, what we can write, dSAB over dt is equal to 5T. So therefore, SAB is equal to, if you do the integration, then we are getting as 5 over 2T square. Okay. Here we are neglecting the integration constant. So therefore, if you plot it, then you will get this kind of parabola in upward direction, in positive direction, up to 10 seconds. It would be up to 10 seconds. Next for BC. Next for BC we have constant velocity. If you remember, we have constant velocity. So the constant velocity was 50. BC. So TSBC over dt is equal to 50. Therefore, SBC is equal to 50T. This is the straight line. So again we will plot here straight line up to 10 seconds. Okay, up to 10 seconds. This is your 10 seconds. Next 10 seconds was for CD. Now you see that since in the figure everything is same with like AB, but only we have the negative acceleration. So in a similar way we can draw it as parabola but in downward direction. Okay, here we are getting the parabola in upward direction and here the parabola would be for CD, it would be downward direction. So we plot it with downward direction up to 10 seconds. To 10 seconds. So this is your for AB. Okay, this is for BC and this is for CD. Okay, this is the graph. This is for displacement time graph. Okay. I hope it is clear to everyone. If you have any question, you must let me know in the comment section. This is your next numerical. You see that the figure is given. What we have to find out, velocity time graph is given, VT time graph, VT graph. The acceleration here you have to find out and the displacement in 0 to 10 seconds. So first we have to find out A, acceleration A from 0 to 10 seconds. V and T is given. So can you remember what I told to you? If A is given, A you have to calculate and V and T is given, then the formula is dV by dt. Okay, dV by dt is equal to tan theta, which is slope. Now tan theta is equal to, I prefer the formula here, is perpendicular over base. Right. Now perpendicular at the point of 10, then this is the perpendicular. Perpendicular is equal to V2 minus V1 and base is equal to T2 minus T1. Now you see in the figure that V2, the minimum value of V2 is 2 and the maximum value is 8 and the minimum value is 0 of time and this is 10. It is equal to 6 over 10, which is equal to 0.6. This is the value of the acceleration, that is meter per second square. So this is the first answer of the acceleration. The distance traveled in 0 to 10 seconds. Distance traveled means s. You have to calculate. So if you remember, I told you that s is equal to v dt, integration over. That means area under this curve you have to find out. Now there is a way to find out. Let me show you how you can do it. There are different ways, but here I am showing you one way. You see that I can divide here the total area between one triangle and with another rectangle. Okay. So therefore here we have to find out first the area of this triangle, the area, and also we have to find out the area of this rectangle. If I give some name like A, B, C, D, E. So therefore here the area would be is equal to area, very simple, area of ABC, it's triangle ABC, area of triangle ABC with area of ACDE, isn't it? ACDE. So area of triangle ABC is equal to, we can write it as half of your base is AC. AC means 10, right? And your perpendicular is 8 minus 2. I am writing here 8 minus 2. Okay. Plus area of ACD means, AC means here 10 multiplied with CD. CD or AE is equal to 2. Okay. So is equal to half multiplied with 10 multiplied with 6 plus 20. So is equal to 30 plus 20, we are getting as 50 is meter. This is the value of the distance traveled. Next question is the displacement from 0 to 10 seconds. Now here you have to understand. You see that here it is particle. Particle is going from A to B in this direction without changing any direction. From A to B it is following the same direction from A to B. Whenever distance and displacement have same direction, then the value of them also would be same. So that's why the displacement from 0 to 10 seconds will also be 50 meter. Okay. That means distance here is equal to 50 meter. Also displacement is equal to 50 meter. Okay, so this is the answer. Now in the next numerical, you see that the figure is given. The figure here is given and you have to find out the average velocity from 0 to 10 seconds. Okay, from 0 to 10 seconds, here you have to find out the average velocity. So the formula, if you remember, I told you that V average is equal to delta S over delta T. Now delta S means S2 minus S1 over T2 minus T1. Now S2 minus S1 is equal to, you have to put the values. At 10 seconds, here the value is, maximum value of the displacement is 100 minus, here S1 is 0 over T2, the maximum value 10 minus 0, that is equal to 10. This is meter per second. Now next one is about the instantaneous velocity. The instantaneous velocity. Also you remember the formula V instant In case of V instant, this delta will become absolutely right, d, ds over dt. So here you see that first we have to calculate for t is equal to 2. Now here at t is equal to 2, suppose this is the t is equal to 2. From, if I give some name A to B, this is the point B, A to B, here you see that the slope is same. If this is your theta, then theta is remaining same from A to B. Therefore, as I told you that ds by dt is equal to tan theta. Tan theta. Tan theta is equal to perpendicular over base. All this formula you just try to put in your mind, okay, forever. You don't forget it. Perpendicular over base. Now perpendicular means for this triangle, here the perpendicular, here you see that 50 here is the value, that means 0, 50 minus 0 is the value of the perpendicular, and the base would be from 0 to 2.5. So you just put the value 2.5 minus 0. Okay, that means 50 over 2.5. So if you calculate it, you are getting the value as 20. That is meter per second. This is the instantaneous value. Next, for t is equal to 5. For t is equal to 5 means at this point, right? Now you see that if I give some name from B to C, okay, B to C, you see that the graph is nothing but a straight line. If it is straight line with your x-axis, that means theta is equal to, here theta is equal to 0, there is no slope. Theta is equal to 0 because tan theta here is getting 0. So if I write it here, V instant for t is equal to 5 is equal to tan theta is equal to 0. Okay, this is the value for t is equal to 5 since theta is equal to 0. Clear now? Next we have C to D. We have to find out the instantaneous velocity for 8, that means C to D. D is this point at 10. Okay, at 10 you have the position 100. So therefore you have V instant at t is equal to 8. Now here you see what we are doing. Again the same formula, tan theta is equal to perpendicular over base. Now is equal to here S2 minus S1 over T2 minus T1. Now see what's the values of them. Here the maximum value is displacement is here 100 minus 50, and here the minimum value of time is 7.5 and 10, right? This is the values. These are the values of them. So therefore I just put it here, that is 100 minus 50 over T2 means the value is, it was I think 10 minus 7.5, right? 10 minus 7.5. So is equal to 50 over, here it is 2.5, which is nothing but 20 meter per second. And the last one is at t is equal to 12 second. That means at this point. So if I give the name E as E, then for DE we have V instant for t is equal to 8. Sorry, it would be 12. It was 12. T is equal to 12 is equal to 10. But here you see that it has negative slope. That means minus theta it is. So therefore tan of it would be minus theta is equal to minus tan theta. Minus tan theta is equal to again perpendicular over base is equal to again same formula that is your S2 minus S1 over T2 minus T1. So is equal to the value of S2 here is, see that it is 0 and it is maximum value is 100. So 100 minus 0 over the value is here 15 time 15 minus 10. So 100 minus 0 over 15 minus 10. That means 100 over 5. So which gives you again 20. But there is some negative value minus. This minus. Okay. So the minus 20 meter per second. Now here is your last numerical, the 10th numerical. I'm sure that since you already know, you already have the idea about STVT graph and how to calculate the given terms, that is displacement, velocity from the given graph. You can do it by yourself. So here you see that velocity time plot is given, that is Vt. Now you have to calculate the distance traveled in 40 seconds, right? Now see that here we are getting two triangles, so let me give the name of them, A, B, C, D, and so you have to find out distance from Vt. So as we know that V is equal to ds over dt, since distance is asked to calculate, so S is equal to V dt. Integration means absolutely right, area. So is equal to area of triangle ABC plus area of triangle CD and E. Now here you see that area of ABC, how to calculate? Area means half multiplied with your base, that means 20 multiplied with 5, that is height, plus area of CDE means half multiplied with 20 multiplied with 5. Here we don't consider the negative sign because this is your distance, which is your scalar quantity. So that's why here we only consider the magnitude. So 20, 10, 10, so 50 plus 50 gives you the 100 meter. So this is your total distance. Next is your average velocity, right? So average velocity means V average velocity is equal to total distance over means displacement. Since it is velocity, so it will be displacement over total time. Now we have calculated total distance, but total displacement, how to calculate? Total displacement, see the story is same, means total displacement here, suppose S vector symbol is equal to integration over V dt. That means again we have to consider here the area. Area is equal to here same the area of ABC plus area of CDE is equal to half multiplied with the base, that is 20 multiplied with the height 5 for ABC plus half multiplied with 20 multiplied with minus 5. Here we have to consider because in the previous one we are calculating only the distance, which is scalar quantity, so that's why here we consider only the magnitude. But since here it is displacement, which is a vector quantity, so that's why here we consider the direction, means negative sign of the velocity is equal to ultimately 0. So since total displacement is 0, therefore finally if we calculate it, then V average is equal to 0 over total time is equal to 0. So this is about the average velocity. So thus you have to calculate the total distance and average velocity. Okay.